Hi friends, do you remember that I recently collected a lithium battery for a certain purpose? Today you will find out why I needed this battery. Here is a voltage converter, single cycle, small sized, and quite powerful. A traditional converter can either increase or decrease the input voltage, but this sample can both raise and reduce voltage. How is this possible? A little later I will explain everything. I have various adjustable power supplies with which I test the assembled devices, charge the batteries, and much more. And recently there was an idea to create a portable power source that would cope with all the tasks, in particular to charge portable gadgets, smartphones, and so on, to charge any laptops and also to feed my favorite soldering iron TC100 and some of my cameras. To power all of these devices, we need different voltages from 5 to 24 volts. The battery which I made previously is 14.8 volts, so I needed a converter which is capable of both raising and lowering the initial voltage. Just note one thing. The nominal values of some components on the circuit may differ from those on the board, for example capacitors. The circuit was drawn using standard values of components. I made a board for my needs and preferred primarily compact dimensions. If you decide to repeat the device, then I advise you to assemble several such converters at once, because they are multi-purpose. There are a lot of applications. It can be used for changing gadgets and as a power source for LEDs, and the production of printed circuit boards can be entrusted to our partner GLC PCB, one of the leading manufacturers of PCB of any complexity and size. The cost of the board starts from $2 for 10 pieces, and free shipping is available for the first order. A link to GLC PCB website can be found in the description. Specifically, my power supply provides an output current of up to 3 amperes. I do not need more. This is due to the fact that I have a small capacity for storage capacitors, but the circuit is capable of providing an output current of up to 5 amperes, so that it is universal. It all depends on the capacitance of the capacitors, the choke, the field effect transistor, and the diode rectifier. So let's start studying the circuit. This is a single-ended converter based on the PWM controller UC3843. Since the voltage from my battery is quite high, so for the smooth work of the PWM chip, I had to add a 12-volt linear regulator to the board. It is not indicated on the circuit. When assembling, you should pay attention to the jumpers that are on the board. 2 of them are a power. Hence should have at least diameter of 1 millimeter. The transformer, or to say precisely, is the choke, is wound on a yellow and white ring made of powered iron. They are used as the output filter in computer power supplies. The size of the core which I used is now in front of you. The choke contains 2 equivalent windings. Both are wound with a wire of 1.2 millimeter. But I advise the diameter to be slightly larger, about 1.5 to 2 millimeter. Number of turns is 10. Both windings are wound at once, naturally in the same direction. Before installing the choke, jumper should be sealed with a Kapton tape. The operation of the circuit depends on the correct installation of the choke. You must keep an eye on the beginning of the windings and simply set it as shown in the video. The power transistor can be any low voltage N-channel field effect transistor with a current of 30 amperes. In my case, the transistor IRFZ44 was used. The output rectifier is a dual diode in the TO220 package. It's very desirable to take Schottky diodes because they have a minimum voltage drop, hence minimal losses. Such diodes can be also found in the computer power supplies where they are used as an output rectifier. That package includes two diodes, which in our circuit are connected in parallel to increase the total current and further reduce the voltage drop on the transition. Of course, the converter is stabilized, has feedback. The output voltage is set by the resistor R3. It can be replaced by a conventional variable for ease of adjustment. By the way, our converter is equipped with protection against short circuits. As a current sensor, the resistor R10 is used. That is a low resistance shunt. The larger the resistance, the lower the tripping current of the protection. If the protection isn't needed, then this part can be excluded. Another of the protections is a 10 amperes fuse. In general, in my case, there is no need for protection since the control board for the previously collected battery already provides protection from any evil. The capacitors used in the circuit are very desirable to take with a low internal resistance. Power elements, transistor and rectifier are attached to the aluminum plate. Don't forget to isolate these elements from the radiator using plastic bushings and heat-conducting insulating pads. Thermal paste is also desirable. Thanks to PWM controller, this converter has a very high efficiency. No load current depending on the supply voltage can be 20 to 40 mA. Now let's do some tests. First of all, let's check the range of output voltages by applying 12 volts to the input. The maximum output voltage is about 25 volts and you can raise more, but I will not risk it since my capacitors are for only 25 volts and with a further increase of the output voltage, they could explode spectacularly. The minimum voltage is about 5 volts, which means that you can safely charge the smartphones. Stabilization works fine with changes of the input voltage around 10 volts. The output keeps strictly within the specified value. Despite its compact size, this kit provides an output current of about 2.5 to 3 amperes, almost without a drawdown of the output voltage. But, as it was said earlier, currents of 5 amperes or more can be got from this kind of circuit. In addition, I will say that the power tracks of the printed circuit board must necessarily be strengthened with solder, because considerable currents will flow through them. This converter, together with the previously assembled battery still without the box, will help me create new videos for you. I think standalone power supply with the ability to set any nominal and non-standard output voltage will be relevant for many radio amateurs. This video has come to an end. All the necessary links, including a link to the project archive and the components for assembling this converter, are in the description. Please rate this video, leave a feedback, and visit our group on electronics. The link is also in the description. On this, I have to say goodbye. Until new meetings, with you was Kassian TV.